Hi students, today we are going to prove this proposition. So this proposition essentially says what is the role of torsion for a space curve. As I said earlier, I mentioned that torsion is a measure how much a space curve deviates from being a plane curve. That means torsion is equal to 0 means that it is a plane curve, and when torsion increases, the curve rises from that plane. അതായത് ഒരു പാമ്പ് തല പൊക്കണെ പോലെ പാമ്പ് നിലത്ത് കിടക്കുമ്പോൾ ടോർഷൻ ഈസ് ഈക്വൽ ടു 0. തല പൊക്കുകയാണെന്നുണ്ടെങ്കിൽ ഇറ്റ് മീൻസ് ദാറ്റ് ടോർഷൻ ഈസ് പോസിറ്റീവ്. So that's what this proposition says, that gamma be a regular curve with non-zero curvature so that torsion is defined everywhere. Then image of gamma is contained in a plane if and only if torsion is equal to 0. That means for a plane curve torsion is equal to 0 and vice versa. So torsion measures how much a space curve deviates from being a plane curve. So let us recall some definitions before proving this proposition. So for a unit speed curve gamma, we defined the curvature kappa to be norm of gamma double dot equal to norm of vector t dot. So vector t means gamma dot, vector t dot means gamma double dot, and vector t stands for the unit tangent vector. And we define vector n equal to 1 upon kappa, vector t dot, this is equal to what is kappa? It is 1 by norm of t dot times vector t dot, so that n is a unit vector, and n, it is perpendicular to t. Why is that? Because t is a unit vector, it is the unit tangent vector, so t dot is perpendicular to t, but n and t dot, they are in the same direction, so n is perpendicular to t. And finally we defined another vector, vector b, it's called binormal vector, that is equal to t cross n, and this t comma n comma b forms an orthonormal basis for R3, and it's a positive system, means t cross n equal to b, n cross b equal to t, and b cross t is equal to n. That is what is meant by a positive system. And I differentiate this expression b, so I will get b dot equal to t dot cross n plus t cross n dot, but t dot and n, they are in the same direction, so t dot cross n is the 0 vector, so you are left with t cross n dot, b dot equal to t cross n dot. So look at b dot, it's a vector perpendicular to t. Also b dot is a vector perpendicular to b. Why is that? Because b is a unit vector. B is a unit vector follows from here, because t and n are unit vectors. So b dot is perpendicular to both t and b. Therefore b dot must be parallel to n. Therefore b dot is a scalar multiple of n, and that scalar is denoted by minus tau, and that tau is called the torsion. Remember, torsion is defined whenever curvature kappa is non-zero, because here in the denominator kappa comes. So these things you know. And now we will prove this proposition. Okay, so proof of proposition. So assume that image of gamma is contained in a plane. So do you know how the vector equation of a plane will look like? For a plane to be defined, it should have a particular slope. That slope can be determined in two ways. One is the x slope and the y slope. That means the tangent or the angle it makes with the x and y axis. So this is one way of looking at the slope of a plane, and another way of looking at the slope of a plane is if you have a vector perpendicular to that your plane lies. So you have to control only one thing, namely this vector n only. If this vector n changes, that means instead of this n, if your n is like this, then the plane is like this. Understand? If your n is like this, then the plane is like this. So you don't have to control two things, namely the so-called x slope and y slope. You have to control only one thing, namely this vector n. So this determines the slope of that plane, the so-called slope, and v, it's a point through which the plane passes. So this is the vector equation of a plane. If d equal to 0, you have a plane passing through the origin, and for non-zero d, you have plane parallel to the plane which passing through the origin. Okay, so assume image of gamma is contained in this plane. What I have to show? The torsion is equal to 0. Now the assumption image of gamma is contained in this plane means that V can be chosen as gamma of S. So gamma of S inner product with n equal to d. Now you differentiate. So gamma dot inner product n plus gamma inner product n dot equal to derivative of the right side 0. But I can assume n is a constant unit vector. As far as a plane is concerned, this n can be chosen as a unit vector, and it's a constant. Not just the magnitude remains the same, the direction also remains the same, because you are having a plane and a vector perpendicular to it. So if you look at any point on that plane, n will be perpendicular to that plane. So the direction of n doesn't change. Similarly, magnitude doesn't change. That means n is a constant unit vector. So n dot equal to vector 0. So gamma dot n dot is 0. So this expression rewrites to gamma dot inner product n equal to 0, but gamma dot is t dot n equal to 0. This is expression 1. You differentiate again. So t dot inner product n plus t inner product n dot equal to 0, but n dot is again the 0 vector because n is a constant vector. So this expression is 0. So you will get t dot inner product n equal to 0. But what is t dot? What is t dot? It is kappa n. T dot is kappa n. So kappa times small n is the normal vector. Inner product with capital N equal to 0, but kappa is non-zero. That's what we assumed in the beginning. Kappa is non-zero. So you will get small n inner product with capital N equal to 0. So this is 2. Therefore capital N is a vector perpendicular to both small t and small n. Therefore, come on, n must be parallel to vector b. N must be parallel to vector b. But capital N and this b both are unit vectors. So therefore n must be equal to b, or n must be equal to minus b, or in other words b must be equal to n or b must be equal to minus n. But b is a smooth vector. A smooth function cannot take two distinct values. That is because of intermediate value theorem. A continuous function must take every in between values. So an application of intermediate value theorem says that b is either always n or b is always minus n. That means b is a constant vector. B is a constant vector means b dot equal to 0. But what is b dot? What is b dot? It is minus tau n. So minus tau n is equal to 0. But n is a unit vector. So this expression will tell you that tau must be equal to 0. Remember, the right side here is 0 vector, not the scalar 0. So I write vector 0. Where is that? Yes. I need a pen. Yes. So this means that tau equal to 0. This proves one side. Okay. Hope you understand. Conversely, assume tau equal to 0. I have to show image of gamma is contained in a plane. Which plane? We don't know. But then tau equal to 0 means b dot equal to 0. Right? Tau equal to 0 means from this expression b dot equal to 0. From this expression b dot equal to 0, that means b is a constant vector. B is a constant vector. From our experience from the previous part, image of gamma was contained in the plane b dot n is equal to d. Okay. Which v, which n, which d, we have to determine all these things. Which is this plane? We have to determine all these things. But from our previous part, b was either n or b was minus n. B was either n or b was minus n. And in the previous part, we started with image of gamma was contained in the plane b dot n is equal to d. Therefore, we start with b instead of n. The natural choice for n is b. So this is just a guess. Image of gamma is contained in the plane v dot b equal to d. So the question is again which d and which v. V, as far as v is concerned, there is no problem because v is just a point in that plane. So I can take v as a gamma of s naught for some s naught in the domain of gamma. So this is just my guess. For n, this B will work. Therefore, we consider d by ds of gamma of s dot b. This is equal to gamma dot of s inner product with b plus gamma of s inner product with b dot. Okay, but b dot is the 0 vector. So this part becomes 0. This inner product becomes 0. And gamma dot is t. So this becomes t dot b. But t and b are mutually orthogonal. So t dot b equal to 0. So the derivative of this is equal to 0. That means this is a constant. Gamma of s inner product with b is a constant. And that constant, let it be d. This means that this gamma of s inner product with b equal to d means that precisely image of gamma is contained in the plane v dot b equal to d, where v is gamma of s naught for some point s naught in the domain of gamma. So this proves this proposition. Hope you understand. Thank you.